Problem 4 actually gives you two pieces of information about a line without making you find them yourself, right? It's saying, suppose I have a line whose slope is 5 and whose y-intercept is -6. How do I find a slope-intercept equation for that line? What did you say? Yeah. So given that I have a slope and a y-intercept that I know, I should use the slope-intercept template, y equals mx plus b, to find my equation. And in that template, there's only room for two parameters. The y, the equal sign, the x, and the plus, those are the same regardless. So all we have to do is drop in the value which we know to be our slope, that's 5. So that goes here, attached to the x, the coefficient of my x. And then also the value of the y-intercept, which we know to be -6. Whoops. So I'll just put -6 into that slot. And then the only other thing we might do is simplify the addition of -6. We can rewrite that as the subtraction of +6. Keep, change, flip. And that's as much as we need to do with that. It's when we don't know off the bat what the slope is that we want, or when we don't know off the bat what the y-intercept is that we need, those are the times when now we have more work to do. And so problem 5 is such an example. But as you can imagine, if we can get to a place where we know the slope and the intercept, then we can do what we just did on the last problem and just drop that information directly into the slope-intercept template. And again, be done. So there is kind of a short way to approach this that I saw some of you take in your work that I'd like to talk about together, because oftentimes people find that this is the shorter way to the answer. So it really just poses us two questions. What is the slope? And then afterwards, what is the y-intercept? If we can answer those two questions, then all we have to do is stuff those two things into this template and then walk away and be done. So first things first. How do I find the slope of this line? Or how did you find the slope of this line? So we know we have a formula that tells us, given 2 points, how to find the slope. That's this y2 minus y1 over x2 minus x1 formula. So to use that formula, all we needed to do was label the coordinates of the 2 points that are labeled for us in the diagram. And the reason they're labeled on the graph is so that we can be sure that the graph is actually going through those lattice points, the whole number of points that we see. So we can reasonably infer that the coordinates -4, 3, and 1, 6 are points that lie on this line. And then if we use those as our points, we can choose x1, y1, x2, y2 in whichever order that we like, as long as we're consistent. So maybe we'll make this one our point x1, y1, and this one x2, y2. And if I do that, then y2 minus y1 is going to be 6 minus 3. So let's move that over to here. 6 minus 3. x2 minus x1 is going to be 1 minus -4. So upstairs I end up with a 3. Downstairs, what's 1 minus -4? Yeah, well, keep, change, flip is going to make it 1 plus +4. So actually what I get there is +5. But my slope turns out to be the rational number 3/5. Which, by the way, if we had made the opposite choice for which one was x1, y1, and which one was x2, y2, then it would have just flipped around into 3 minus 6 on top and -4 minus 1 on the bottom. And if I did that subtraction, I'd get -3 divided by -5, which is what you said in the first place, right? But what do I get when I divide -3 by -5? I get the same thing as when I divide +3 by +5, right? Negative over negative, the same thing as positive over positive, right? The negative signs cancel. So whichever way we slice it, we're going to get the same slope. The slope is 3/5. One other place. Did anybody, by the way, get the slope of this line without doing that arithmetic? What did you do?
We actually did rise over 1.
Okay.
Points.
Uh-huh.
So from the -4, 3 point,
Mm-hmm.
we went up 3.
Okay.
And then we went across to the other point up.
Great. So by using the graph, going from one point on this graph to the other point on the graph, you made the argument that we have to go up 3 units and to the right by 5 units to get from that first point to that second point. So what you really did is you found these differences, 3 and 5. You just found them not using arithmetic, but by counting little squares on this graph. Right? It's the same information. Just one way it's given to us in a formula using arithmetic, the other way it's given to us by the graph. And all roads lead to Rome. All we have to do when we use the counting grid squares method is remember which order to divide those two things in. Right? Divide the rise, in other words, the vertical difference, divided by the run. And that's where my 3/5 comes from. That's nice because that also lets us go back and forth. Given a number which we know to be the slope of the line, that also tells us how to use that number to help create the graph, and that's something we're going to talk about next. Right? So yeah, whichever way you do it, 3/5 is the slope of this particular line. So that's good. That means that now we have almost everything that we need to determine an equation for this line, but what we're missing is b, the y-intercept. So now the question is, how do I find the y-intercept of this line? One of the ways we could try to find it is graphically. At least this will give us a sense of about roughly where the y-intercept is. Just looking at the graph, whereabouts is the y-intercept located? Yeah, it looks like 5.5 or so, somewhere that's in between 5 and 6, because again, the y-intercept is located on the y-axis. And that happens to be at a point right there, and it doesn't look like it goes through a whole number coordinate point, but at least it's somewhere in between y equals 6 and y equals 5. And it looks like it's roughly halfway in between, so maybe 5.5? Question mark? Here's the thing about graphs. Graphs, like a lot of pictures, they speak 1,000 words. But when it comes to mathematics, they sometimes mumble those words. We don't know for sure whether this line passes through 5.5, or maybe it's 5.6, or maybe it's 5.42, or maybe it's pi plus 2, or something like that, right? There's a whole bunch of different numbers between 5 and 6 that this could be passing through. It doesn't have to be 5.5. It might not be 5.5. We know it's something between 5 and 6, but we don't know just from the graph with any kind of precision what value it has. That's why we need the algebra that we're going to do now to figure out exactly what is the coordinate of that y-intercept. But at least this gives us a way to check for consistency when we do get an answer. If we do get an answer from this method that doesn't give us a number between 5 and 6, then we should doubt our other answer as being inconsistent with the graph. So let's figure out if 5.5 is actually right, or whether it should be something else. So how can I figure out what the value of b should be using algebra? So if we look at this equation, it's got 3 things that look like variables in it. It has a y, it has an x, it has a b. What we're trying to do right now is we're trying to find a value for b. But I can't do that in this equation unless I get rid of the other variables. Right? I need to have everything except for b be a number. So how can I get rid of x and y in this equation so that I can then solve this equation for b? Well, one thing I can do is just provide this equation with the coordinates of any point that I know is going to be on this line. So for example, I know if this equation actually models this line, then when I feed an x to this equation, which is 1, then the equation should give me a y, which is 6, because this point, 1, 6, is a point on the line that has this equation. So one option that I have would be to take this point and plug that point into the equation. In place of y, I'll put a 6. In place of x, I'll put a 1. And what that does for me is it eliminates the other variables from this equation and leaves me only with a b, which is unknown, that now we can use the tools of solving linear equations that we know from the beginning of our course to solve this equation for b. And that will tell me what my y-intercept is, exactly. Not approximately, not visually, but actually. And all it requires me to do is now some equation solving. Maybe let's clear denominators, just for fun. I'm going to solve this equation my way for a minute. I'm going to use my professor privilege. Let's multiply everything by 5. Because that's going to actually avoid some fraction arithmetic for me. Multiply everything by 5. I'm going to have on the left side of the equation 30. On the right-hand side of the equation 3 plus 5b. And then my path to the finish line has me subtracting 3 from both sides. And then after I subtract 3 from both sides, I'll need to divide both sides by 5. So 27 equals 5b. Now divide by 5. And I'll find out that the value of b is 27 over 5, which is a fraction, which is in its lowest terms. Let's not worry about it any more than this. If you like decimals, it's 5.4. So 5.5, which was our guess, was close. Not quite exactly right, but it was close. 5.4, 27/5 turns out to be the y-intercept we want. And therefore, we should finish this problem by putting that number into our equation template, right? Reminding the reader that what we were actually looking for was an equation for this whole line. And that equation is y equals 3/5 x plus 27/5.